Hey everyone, welcome to the Tom's Hardware Podcast for June 7th, 2022. As always, I'm Tom's Hardware Editor-in-Chief Avram Pilch, joined by Associate Editor Les Pounder, Raspberry Pi expert Ash Hill, and our very special guest, friend of the show, one of the world's leading makers, Brian Corteil. So wonderful to have you on again, Brian.
Oh, a pleasure. Looking forward to showing Zoe off.
So tell everyone a bit about your latest project, Zoe.
So Zoe is a digital Zoetrope. It's based on the Victorian parlor toy that one of the sort of like the early machines that was produced moving pictures. But I've recreated it using the Pironi badges, which are an e-ink thing. So this is when if we hit that button, it's able to change the thing I was saying. This has got a battery hanging off it at the moment to be able to change, and you can also do a few other. So the thing that interested me was the ability to be able to show an image.
Yeah.
The thing insane, and this has a Raspberry Pi 2040 processor on it, which is the little microcontroller chip. Oops, wrong thing.
So are you using several of them for Zoe?
Yeah, we're using 15 of them. So if I just change cameras, so I'm just going to change over cameras. Oops, wrong one. Let's go back, and it should be that one. So that's Zoe.
We still just see you.
Oh, sorry. Yeah, got the right camera, but
there we go.
There you go.
Oh, nice, mate. So there's 15 Badger 2040s in there.
Yeah, there is. So there. Go back to here. So this is the test piece that I made.
Yeah.
For the inserts, and the Badger sits on a 3D printed frame. And
that's brilliant.
As you can see, they're mounted on the back.
Yeah.
So I'm just going to turn my laptop around so I can see the screen, and I'll show you. Actually, I don't need to.
So the whole device is laser cut, I can see.
Yeah, it's all laser cut. So you see the details here, and this is one of the sections, and you can see that 3D printed part is here. So they're all connected.
What material is that?
So it's actually plywood. Most of it's poplar ply, which is a very lightweight wood, a little bit more dense than bolster. Well, thermal bit.
What about the 3D printed components?
So the 3D, there's really only one, which is this one.
Was it just PLA filament?
So yeah, it's PLA. I think so.
That's a nice piece. There's a lot of disciplines gone into there to make this object. So we've got 3D printing, laser cutting, electronics, programming, all to make this one project. It's fantastic.
So I need to connect down through.
That's great. So Brian, you've got all these 15 Badger 2040s, and we've got all these USB connections. How do you get the images onto each of them?
Right, okay. The images are transferred from a Raspberry Pi, which is tucked underneath the Pi juice, via the USB. So the USB provides power to the badges and also a serial input. And the way that we can get the images onto it is either through this touch screen display. So you can choose one of these paths. So if you touch, so I'm going to touch the horse. And if you look at the badges, you see they're updating in real time. Or
That's amazing.
Neat.
The other option is to fill out one of these sheets. So here's some free ones that have been done by other people.
Yeah.
Yeah, I'm not a talented artist when it comes to pit.
You're a talented maker, though, mate.
Things. I think somebody done a love story.
That's great.
So there's loads of different hits. So like just a cat in university. So yeah, took it along to the American people done. Copied them in, and then what you do is that you take the sheet and we go old school. Put it in the scanner.
Yeah.
And then get this one back. You've got this other thing to show you inside of it. There's another Pi tucked away in here. It's connected to the Zoetrope wirelessly.
Press any key. Is that the any key? That big one?
Yeah, that's the any key. I didn't have a chance to label it, but it's going to be labelled the any key.
I love it.
We'll press it. It starts scanning.
Oh, that's a clicky any key.
Yeah.
Right. Wait, is that one of the? Those are one of the novel keys, big clicks or whatever they call it, right?
Yeah. So that's currently scanning. It's a large working key, which I really love about it. I've soldered on connected into the Pi.
And then another Raspberry Pi. So that's 2 Raspberry Pis, 15 RP2040 boards.
Yeah.
Okay, what is the Raspberry Pi logo that something is plugged into?
Raspberry Pi logo. Where?
Is that a hub? That looks like a hub.
The Pi hub.
Yeah, that's a very. There was a USB hub. It was made by Pyronly way back about 8 or 10 years ago.
It's
early days.
It's very early days.
I can remember using one of those to power 3 Raspberry Pi 1s for a project years ago. It just supplied enough juice.
That's awesome. So could you explain how this Zoetrope, like how does the whole thing work? Like once you have the images inside,
so
how does the user use it?
So once the images are transferred over, if we press one of the buttons down here, so sorry, it's a bit. Let's see. So we got the big red button's the emergency stop button that breaks the drum, stops it from spinning. The yellow button's the stop button, and then we've got 2 directional buttons. So if we press and then you have to look through the slots to see the picture. I'm just going to transfer myself over.
That's awesome.
So I have, if I got it right the right way, I'm just going to quickly check. So where's the phone link? I still don't know. So where's my mobile phone? I'll see if I can find a picture of it.
No problem. So it's interesting to see the whole drums spinning and the Badger 2040 spinning as well.
Yeah.
Because they're still connected to the USB. Is that right?
You got the Raspberry Pi in the center, and they're all connected up on the USB. The images are static, most of the time static when Zoe's spinning. There is actually it uses something called a split ring that transfers the power up over up to the Raspberry Pi on the top. So, and you may have noticed there was. Let me swap the cameras again. So, you may have noticed the battery on top of Zoe. Oh, sorry,
Yeah.
This is a Pi juice, which is like a UPS, a battery supply thing. So if there's any interruptions, my Zoe's spinning, it won't affect. Yeah, but then you've got this thing here. So if you look, I don't know how well you can see, but down this hole, so you can turn round without interrupting, and that is.
Wow.
That looks awesome inside.
So you've got this bit here. Can you see this black thing that I'm pointing at?
Yeah.
Yep.
That's a split ring. So that means that the wires can turn around and still making connection. And then underneath here, got the motor. And got the small clock, and when Zoe turns, this is the bit that's powering round, and the so we've got another Pico, so there's 16 Picos in effect. You think, and that's connected to. So the Pico is actually controlling the motors. Controls that motor, and the spinning is connected to the buttons.
Yeah.
And then as you stop, and then there's on this side, I don't know, can you see where the red light's glowing?
Yeah.
But another power converter, same as this. So I've got a 5 amp power supply feeding the Pico down thing. I plan to add lots of useless LEDs.
LEDs are never useless.
I'm hoping to put them between the drum and the bass, and make it so it's all glowing blue. Hopefully, making it look like it's floating.
That's awesome.
That's really neat.
That's a great piece of work, mate. I'm also interested the Pico that's running the motors. I'm guessing there's a motor controller involved. Which one have you used?
Oh yes, it's tucked inside, so I can't really.
It's okay.
Let me have a look. I did take some photographs. Somewhere. It's basically an Adafruit, the 8833, I think, off the top of my head.
Oh, that's not what I'm familiar with.
Let's see if I can find.
No worries. Is it what chip's controlling it? Is it like L298 or L3910 or something like that?
It's a TI. I'm sure it's an 8033. It's like the Big Brother version of the one that they use on Pironi use on the Explorer hat and that.
Oh, DRV 8833.
Yeah, something like that.
Yeah.
But it's able to take a wider voltage range because I'm feeding the motor 12 volts.
Yeah.
Whereas the Explorer one tops out at about 10.8 volts or something, if I remember on top of my head.
Yeah.
Let's see if I can find that.
It's that thing when you're looking at making stuff move, and something needs a lot of current. You've got to pick the right motor control, otherwise it's just going to get really hot and go bang fast.
Yeah, it's always you need to fit the right controller to the motor. It's essential.
Yeah, I know that because I've done it. I made the mistakes other people don't.
So it's Yeah, we've all been there.
Oh yeah. So you were at EMF Camp over the weekend, the big outdoor hacker conference in the UK.
Yeah. Yes.
How did Zoe go down with all the delegates there?
Really well. Yeah, people were very. Oh well, they were impressed by the build, and they really loved the idea of being able to transfer the images over.
Yeah.
And be scanned.
That extra detail adds a lot to the whole project.
Yeah.
I found going to maker events and stuff like that is that the more interactive a project is the more that is appreciated by people. The only people that really appreciate a static display is other makers, because they know how much work has gone into a project, whereas with the general public, it's having something that they can touch, look at, and control. And I wanted this project to be able to take along to things and have something that was interactive enough and for people to put their own art onto it.
Yeah.
So that's the whole point of the design sheets.
That's a good idea, that, because you could just have 4 or 5 different designs and people would just press buttons and play with those. But to have their own input to it is fantastic. It gives something personal from them to the project.
And I'm also wanting to be able to do to be able to do simple animation workshops with kids, so they can do their own designs, animate them and put them up onto Zoe, so they can actually see what's happening. And in a workshop situation, they'll be able to do it 3 or 4 times and improving it each time when they see the differences they're making with it. And also at the same time teaching about persistent vision, and that's how all type of displays work. So from the early days of film, right up to how a computer monitor works, basically.
So how do you transport that? It seems like something that would be difficult to transport.
When I was making it, I didn't actually work out that I would need to fit it through single doorways, and it just fits through a single doorway. It's a pain to transport. It is big.
But it comes down into parts, doesn't it? It breaks down into sections.
No, the sections are glued together, so I have to transport it as it is. I could separate it into separate rings. When I put these together, I need to see what you're looking at. So yeah, when I put this together, the idea was going to be modular, but because of the design, all these were at different places, so I had to tie them together with something. So there's little running straps that run between each section, and they're glued. So for me to change it, I would actually have to break the joints to be able to separate them. So yeah, it basically takes up a load of space in the back of the car, but it's worth it.
How long did it take you to create the final project from the first time you had the idea till it got put together?
I have actually already made one of these about 8 years ago, and I use OLED displays. So I had a good idea of how I needed to. Actually, I used a slightly different construction technique, but the idea I've been ruminating on the idea since the last EMF, which was 4 years ago, and I was thinking of how to transfer. The last one I made had a slight problem that when it spun, it used OLED displays.
Yeah.
And you could actually see the LEDs refreshing as it spun, because it just happened to have the same frequency of it spinning as their refresh rate was, and you see a black line going through the OLEDs.
Yeah.
And this is really like before that e-ink was available to the general, to us makers. It was still very, very expensive. You only saw it really in Kindles. But since it's sort of been starting to be used to be used on sort of for labeling for prices in supermarkets and stores, the cost of them have dropped down really thin. And I was hoping to make it and get a grant from EMF to be able to use full color displays, but it would have been extremely expensive, and it was out of budget for EMF to be able to provide a grant to cover it.
Yeah.
But Paul from Pyrone contacted me and said, would you like some badges to make the Zoetrope? So I started from there, and I basically designed Zoe in SolidWorks in 3D, and expanded it out, and the rest of it I've made up as I went along. But I've CAD each part once I know what I needed to make. There's you weren't able to see it, but that's the motor controller that I found. No, that's not the motor controller. So where's my photos?
So while you're looking for the photos, just a quick question from Kevin, who's in the chat. Is there a minimum number of sections needed for a Zoetrope?
I don't know. So I normally work on the speed of what old film runs at, which is about 12 frames a second. So I would say some kind of multiple of that. So maybe 6 would be the minimum. I would build one. But so my last one was 12, and the other one, and this one's 15. So the reason that this one being 15 is so it can. There we are. So, oops. So yeah, it's 15 frame. I'm aiming for 12 frames a second, but with 15 frames a second, the refresh rate on these are quick enough. They're refreshing less than a second.
Yeah.
That I'm able to update it round, and there'll be three or four frames that stay constant. And if you look at it from one direction, it will look like it's continuously updating. So, in theory, Zoe can be an infinite Zoetrope, which means you could play a film through it instead of just 1 second or 1.25 seconds.
But would it fit through a door?
Yes, it does fit, just about fits through a door. Thank God. and just about in the back of the car as well. So so this picture here is a picture of a sensor I made to be able to detect the home position of Zoe, so I can work out the frame rate and also use it to upload the next image when it's in infinite Zoe mode. And this was one of the 3D parts.
Brian, we can't see the picture. We can see you, not the picture.
Oh, okay. You can see me. Let me change it. So, sorry about that. There
okay, mate.
Can you now see it?
Yeah, can see it.
So, yeah. So it's this point here, this here. So using the distance sensor, you can actually see in this picture. Can you see a piece of paper that's?
Yes.
Yeah.
So when that goes past the sensor, the Pi is able to detect that it's gone past the home position. And this is mounted on a 3D part that I designed to hold it. I don't know, may have some pictures of the internals. So that's just another view. You can see the 3D put it into Park and a Pico, and the power supply's out of thing.
I see a cat.
Oh, that's not my cat, but that's my cat.
Hey.
It's a
That's
great
Patch.
cat.
We all know Patch. We've seen Patch on Twitter.
He's a great character. He's a little sod. Sorry, a little devil. But he's a thing. So these are some of the. Have I got more?
How many hours do you reckon you've put into this project?
I've lost count after about 120, I think.
Blimey.
I've had two long weekends over 3 days before EMF. Some of the days were over 12, 14 hours. It sunk a whole lot of time. So that's the top of the big button box, or top down view. It's just sunk time. Unbelievably.
That's awesome.
That is so. It's just so amazing.
Well,
it's so amazing what you've done here. Just absolutely super impressive, and a great learning experience for the kids who get to experiment with it. So that is really awesome. Speaking of things that people get to design with, Les, you've been using a new piece of software that allows you to more easily design 3D models.
Yeah, I've been messing around with OpenSCAD or OpenSCAD, however you want to pronounce it. It's a bit different to a normal way of producing 3D models. So normally we could use Blender, or we could use something like AutoCAD to produce a model, or something like Tinkercad, which I've got here. But you may not be that way inclined to make models. You may not want to mess around with these packages. Sometimes they're imprecise. You can't work out where the X, Y, Z angles are. You get confused. So you can do it in code. So OpenSCAD is what I'll call it. You write code in the top left of the screen, which produces objects in the view area. So this is live. This is actually on my screen right now. So I'm going to go into that app. And you can see I've got a very random shape. This was me last night messing around to learn this package, because I've just got an Ender 2 Pro 3D printer, the third one that I've got now. And I want to play around with that printer with OpenSCAD to make models and see what I can make with it, really. But I'm going to change this model ever so slightly. So I've got 2 cylinders. In fact, I've got 4 cylinders because it's 2 on top of each other on the top and at the bottom. So I'm going to change the top one. This is where I get it wrong, but we'll soon see. I'm going to change its radius from 5 to 10. And on the bottom one, change that to 10. And I'm going to click on a little preview button. And it's rendered it for me. Give me a preview. So I can see the object now has this wonderful shape that looks like a dumbbell and a Rubik's Cube mixed up. So I'm going to render this now into a file. That's the render done in less than a second. And I'm going to export that as an STL. And I've got a file called show on the desktop. There we go. And now I'm going into the second part. So this is Prusa Slicer. And I've chosen this one because apparently it's got better slicing options for the Ender 2 Pro. The Z-axis, when it's slicing, it produces better quality slices. I don't know the technical terms just yet, still learning, but apparently it's a bit better. So this is the build plate of my Ender 2 Pro. And I'm going to import the STL that I've just produced, show. And there you go. That's the object that I've just produced in OpenSCAD. And I've just sliced it. Again, nice and quick. I can see how it's all made up now. So I can send this to the printer when I need to, and it's ready to go. I just thought this was a lot easier to work with than something like Tinkercad. With Tinkercad, I have to export it as an object or an STL or something like that. With, you can't see this, can you? I've got different screens. Here we go. So with OpenSCAD, the text in the left-hand side, I can just copy and paste and send it in an email to someone. They can paste it into their OpenSCAD, and it produces the file ready to go. So there's only kilobytes of data rather than huge megabytes of files. So that's what appealed to me. It looks like it could be fun. Don't get me wrong, Tinkercad's nice. I like Tinkercad. I made this by extruding an SVG a few weeks ago just to play around with. But the whole programmatic way of doing it appeals to me, producing objects and things with code. So I'm going to give it a go, and I'll let you know how I go on.
I love that idea, because sometimes with Tinkercad, it's just so dependent on you dragging your mouse around and like, oh yeah, you want it to be exactly the size, you got to drag it. It's not precise enough, and I'm much better at typing than I am at dragging mice around to be precise to the millimeter. So,
well, that's it. With this, you just say, I want a cube, and you can specify the cube's general volume, so 10. And it just goes, bang, there's a cube. Or you can specify if you want to make a cuboid, all the axes for it, spheres, cylinders, pyramids, anything that you can do in geometry, you can build in this with just a few lines of code. And you can even create functions that can also generate objects for you. So you can just call the function, and it just goes pop, pop, pop. It's all ready to go.
Can you reverse engineer? Can you take something that's already an STL file and import it into this and see the code for it?
Let's see. Let's go to open file. If I can open show, it's looking like I can't. I can't have an option for STLs, and there's no import functionality. So we're going to say that's a no.
Oh well, that would be ideal, but I guess that's hopefully someday they'll do that. But
we've all got our limitations.
What do you think, Brian? What do you use primarily? Do you use Tinkercad? What do you use for your designs?
Sorry, someone's playing with Zoe. For most of my design, I use SolidWorks or Inkscape. We're lucky, being a member of Makespace, able to get a hobbyist license for free for SolidWorks.
Very cool.
And I find it works really well. The way that I learned to way back in when I was a kid to use a drawing board to draw. So I'll do technical drawing and construction with lines and shapes and stuff like that. And that's the same way that I can use SolidWorks to make stuff. And I find Inkscape sometimes, if you just want a quick, dirty way of making something, that Inkscape is a quick way to do it. And yeah, so they're the main two things that I use for doing my design work.
Awesome.
Have any of you guys played around with Blender before?
Yes.
No.
A little bit. I found it very hard to use.
It's got a learning curve, but I think it is worth it because it is open source. Anything you make, you have the rights to. Whereas if you're using something like Fusion 360, you don't have that unless you bought a license. But I know that one thing we appreciate is the ability to specify exact units, exact measurements. And being in Blender, you do have the option to drag and drop points if you want to freehand something. But there is also the ability to type in numbers to be very precise with what you want to, where you want your point to be or how big you want your object to be. So it does take a little bit of time to get into the groove, but that's another option out there.
Blender is good. The Raspberry Pi Foundation have got some learning aids for Blender where they teach kids how to create a scene, like a house and a snowman and a car driving around scene. That's really good. But I'm going to date myself now about how old I am. Precursor to Blender and all that was something called Lightwave. And Lightwave was used in the mid-90s by, what TV? Babylon 5, a TV show. They used it with the video toaster.
Oh, cool.
So I was using Lightwave on an Amiga 500 with 1 meg of RAM and 7 megahertz CPU.
Now
It took days to render.
That's incredible.
I remember the software, but I don't never used it.
I just want to throw a pitch in here for my favorite movie, Tears of Steel, which was made completely with Blender.
Neat.
Everyone should watch that 10-minute movie because we use it to test stuff. It is a completely open source movie, so I learned about it from other people doing demos because it's like they can't get in trouble for using it.
That's an interesting concept, an open source movie.
Yeah,
Big Buck Bunny was the first one.
Yes, that's an animated, but this is a live action with special effects. So the Tears of Steel. So Ash, I understand, speaking of virtualizing things, you wanted to show folks how you use a virtual machine to help simulate Pi.
Yeah, if you guys watch the podcast on a regular basis, I usually open up a VirtualBox with Raspberry Pi OS just because it's easier to link it up with OBS, because in OBS you can point it to just a window, and they've made an ISO file that you can use for Raspberry Pi OS, and it's super easy to get started with it. And I thought I'd just go over how to get it set up. So let me go to OBS actually and switch over to VirtualBox. If you've never used it before, it's made by Oracle, and it's really super duper handy for not just creating Linux-based virtual machines, but Windows and Mac, all kinds of stuff. And I have a little one that I've already put together for us here. It's 32-bit Debian, but you can make it 64-bit if you wanted to. And the way that you point it to Raspberry Pi OS is you just go into, we make a new machine, specify those settings that it's a Debian operating system in whichever bit, go to settings. It's not going to open for me because I'm live. Oh, yeah, there we go. I don't know if you can see the pop-up box. I don't think you can. But you'll have a storage option, and you can point the optical drive to the ISO file for Raspberry Pi OS. And if you want to get a hold of that file, then you've got to go to the raspberrypi.com website. And you can just download that to your desktop or wherever you want to put it and point VirtualBox to it. And I'm going to launch my virtual machine here, and it's going to load in real time for you guys, I swear. Here we go. Real time, Raspberry Pi OS booting up. It's got a countdown. We've got a few seconds before it goes. And there's a few really useful use cases for this. If you are designing an application that you want to run on the Raspberry Pi, but you don't feel like transferring everything over to the Pi or something like that, maybe you want to see if it works in different editions of Raspberry Pi OS, then you should totally load up this virtual machine, give it a go, and break that instead of risking messing up your SD card or having to move hardware around. And it works just like the regular operating system. It's just an ISO file, and you can run it on, I'm actually on a Manjaro laptop, so I'm running Linux on Linux, but you can use VirtualBox on a Windows PC. You can use it on a Mac. So whatever computer you have, it can probably run VirtualBox. And I'm sure there's other virtual machines out there that can run this ISO file, but this is the one that I like to use. It throws some errors, but I swear it opens up to the desktop. Give it a second here, and you're going to see the Raspberry Pi OS desktop. And like I said, it's super easy for sharing example programs with you guys here. I do it all the time. Anything that you want to test that doesn't involve extra hardware, this is what you want to use. But if you want to test something that involves like a servo or some LEDs, obviously you're going to have a hard time because you don't have the GPIO access to mess around with that. But there you go. There's Raspberry Pi OS running on whatever you want to run it on. And it's that easy. What do you guys think? Have you used this before? Have you ever used a virtual machine of any kind for Raspberry Pi OS?
Yeah, I've used virtual machines a few times. We did a tutorial back end of last year, Quick EMU, I think it was, which would run virtual machines with QEMU, and it would download Windows 11 or Mac OS X, and you're ready to go. It just did it all the work for you. But VirtualBox is fantastic. It's just so simple to use.
Yep. Yeah, I mean, I use VirtualBox a lot. I also use VMware Workstation Player a lot because VMware supported Windows 11 first. I use it on my desktop. I think I've done the Raspberry Pi virtual desktop a couple of times. I've used it a lot for other things like Ubuntu or stuff like that, where I had to recompile the CircuitPython kernel or whatever. So it's very useful to have that environment for sure.
Oh yeah, I've got a 50-year-old nephew who's curious about Linux, and he had zero experience with it. And I said, look, you can go out, buy you a ThinkPad and play with that, or before you do that, get a virtual machine set up, install all these different, I sent him all kinds of different flavors to try, try OpenSUSE, this, that, whatever meant. And he got a good feel for how to install an operating system, what the setup process was like, without having to actually get a machine out and get started.
It's a huge part of my job because, for example, if I want to install to document the install process of how to install Windows or how to install Linux or whatever, I can get that in a virtual machine and then take screenshots of that for a tutorial. But I couldn't do that if that was the primary OS of that machine.
Yep.
So, how about you, Brian? Have you used the virtual?
Yeah, I've used the Raspberry Pi version and different flavors of Linux. And I used it once. My job to recover an ancient build of Windows to run on modern hardware. So yeah, a very useful tool.
Yeah.
Nice.
That is yet another reason why you need at least 32 gigs of RAM on a PC, if not more, so you can have a few virtual machines open at any given time. Well, speaking of time, I want to thank Brian and all of you who are watching and listening for your time. We will be here once again at 7:30 p.m. UK time, 2:30 p.m. Eastern next week, and we look forward to seeing you all then. Bye, everyone.
Bye.